Okay, so on import, I'll turn on the elevation 1. Okay, so in the extruded view, you can see the member properties have been assigned for the columns. Now, some of these members, since they are at a very small inclination to the vertical profile, so on import or the vertical plane, they have been assigned as column properties. I'll turn on the elevation 1. So we will be basically now. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical profile. So on import or the vertical plane, they have been assigned as column properties. I'll turn on the elevation 1. Okay, so for the branch, so we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. So on import or the vertical plane, they have been assigned as column properties. I'll turn on the elevation 1. Okay, so for the branch, so we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 member properties for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. So on import or the vertical plane, they have been assigned as column properties. Turn on the elevation 1. Okay, so for the branch, so we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 member properties for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. So on import or the vertical plane, they have been assigned as column properties. Turn on the elevation 1. Okay, so for the branch, so we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 member properties for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. So on import or the vertical plane, they have been assigned as column properties. Turn on the elevation 1. Okay, so for the branch, so we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 member properties for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. So on import or the vertical plane, they have been assigned as column properties. Turn on the elevation 1. Okay, so for the branch, we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 member properties for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. So on import or the vertical plane, they have been assigned as column properties. Turn on the elevation 1. Okay, so for the branch, we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 member properties for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. So on import or the vertical plane, they have been assigned as column properties. Turn on the elevation 1. Okay, so for the branch, we will be basically now for the branch columns, I'll be using the. Okay, so in the extruded view, you can see them to the member properties have been assigned. That is 76.1, 3.5 member properties for the columns. Now, some of these members, since so they are in the first example, very small inclination to the gravity load vertical. properties on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been assigned as column properties. Turn on the elevation 1. So for the branch, we will be basically now for the branch columns and be using the in the extruded view, you can see them find the member properties have been assigned, that is 76.1, 3.5. Now we will be sorting columns. Now some of these members, since because they are in the first example, very small inclination to the vertical on import vertical grade, they have been
apply the
We will be discussing on the design results, and also verify after we apply windows as well. So I will just unlock the model. Now for windowed application, what has to be done is we need to go to the define, load pattern. Okay, now for the columns, so we will be creating 4 cases, that is WX plus, after we apply windows as well. So I will just unlock the model. Then another will be WX minus. Now for windowed application, then we have a WY plus, go to the define, then WY line load pattern. Now for the columns, so we will be using exposure from shell object for the windowed application. Can review it, whether it has been applied on all the directions for all the shells. So while selecting, even if the frames are selected, the wind load coefficients will be applied only to the shells. So you can now run the analysis. So you can see now the wind pressures, how they are applied after the analysis. Now we'll unlock the model and we'll come to the definition and assignment of the.
Dice que me pegan col bikini, ti pegan sama-sama. Iya.
Now we'll come to the definition of the non-prismatic sections. So we'll go to define section properties, frame sections. Here we will add a new property, and this will be a non-prismatic section. So let's name it tapered main. So for the tapered main section, I have it in my PPT. This will be the shape of the tapered section. So we have the 500 dia section up to the mid height, then it's tapering up to 300 from the mid height. So this is how we will be defining the tapered section. So for the first part, this will be 500 by 14, and the proportional length will be 1. Next, we will be having the pipe section 500 to pipe section 300. So this is the tapered main column for the main stem of the column object. So this will be the tapered branch. So the tapered branch will be from pipe 250 to pipe 200. Okay, so we will basically select all the columns and we will go to assign frame section property. Okay, so this is how the tapered sections are defined and assigned in the model. So you can now run the analysis. Then we can go to the define load combinations. So the load combinations have already been generated for the load cases. Now you can simply click on the start design check. So now coming to the discussion on the design results. So for the purlins, I have, so we basically need to check the unbraced length ratios. So for the purlins, currently I have not considered the usage of sag rods in my particular model. So what can be done is you can simply select the frame sections for the purlins and provide overrides for the minor as well as the unbraced length ratio for torsion, not for the major axis. The major axis will always be 1. So the effect of the sag rods in the purlins will be considered by providing the suitable overrides. So this is where the uh, designer needs to provide inputs in the design stage for getting the appropriate results. Okay, another thing that needs to be discussed here are the results for the tapered sections. Okay, so the tapered sections are also reported with the demand capacity ratios like any other member. Okay, so you can right click on the member and you will get the demand capacity ratio as well as the location of the maximum demand capacity ratio. Okay, you can click on the report. So you will get the summary and the envelope. So this is the tapered main and the location is 7500 mm, which is at the top of the column. That has a section property of pipe 300 diameter, which the program is using for the strength calculations. And the appropriate section properties are also used as per the section. And the PMM demand capacity ratio is calculated as per 9.3.2.2a. So here, since the circular section is a symmetrical section, the SRSS of the moment capacity of the moment ratios are utilized for calculating the demand capacity ratios. Similarly, you can scroll through any one of these intermediate sections, can go to the report and view the uh, report in this the demand capacity reports. Now coming back to the presentation. So here we are discussing on the reports of the C16 column. So for the C16 column, these are the critical demand capacity ratios for 7500 mm location that I had just shown in the model. Okay, so the section properties and the axial force and the MCR values, if you just quickly do uh, a manual calculation check, you can easily verify these values that the program is reporting for the tapered section. Okay, so since the program has uh, limited number of output stations, outputs are calculated at 3.75 and 7.5. You can increase the number of output stations and also verify the intermediate locations. So I have also verified the values at location 0. So at location 0, you have the height or the thickness as 500 mm and the relevant physical properties, the relevant sectional properties are also reported, as well as the axial force design. So you can see if you just carry out a small manual calculation, we'll see that the values are close enough. Now, since the program is considering the number of digits after the decimal point to a higher tolerance, and they are different with the manual calculations, so you will find these values to be slightly differing. Okay, now I will also import a DXF file for the complete truss. So here too, the objects have been modeled within these 3 layers. Sorry, given the same name. So we'll select the units. So I have not set up the ETABS model. So I'll just import the geometry for the demonstration purposes. Okay, so likewise, you can also import the entire geometry from the DXF file. However, you should be very careful that there are no overlaps and connectivity issues. In the model. So, which is why we recommend the usage of the uh, single truss import and the completion of the geometry in the ETABS file. Okay, so there will be better control over the uh, ETABS model once you use the single truss import. Okay, so here I think due to numerous softwares running parallelly in my system, there is some issue. So I will just simply ignore that and we'll come back to this model, to this presentation. Okay, so these are the non-prismatic outputs that we get from the model. Okay, so it is very much similar, only the definition of the non-prismatic parameters are a little different. So thank you for joining in. And I will now take up some questions from the Q&A. Is it a rigid connection frame or axial only frame? No, this is a special moment frame with releases. Yes, this is a ideal structure. The horizontal and the vertical bracings need to be modeled. I have basically created the model for the 3D import demonstration. Okay, now for the tie bracings, see for the tie members, I will just come back to this model. The tie members are initially the tie members have not been modeled in here. However, the effect of the tie members can be uh, introduced by the overrides to the unsupported lengths or the unbraced length ratios. Okay, so when you click on one of these, or you can simply go to the display design info. Here you can check the unbraced length ratios. Now, since this is a out of plane, sorry, it's not in a straight line. The unbraced length ratios are taken as 1. So this is where the users need to overwrite the unbraced length ratios. You can simply select the members and go with the revise overrides. In order to get the lateral restraints. Okay, so by providing the overrides to the individual members, you can make the use of the uh, lateral bracing, or the lateral ties, the lateral ties. So you can either model them or not model them. That is the discretion of the user. Yes, the wind pressures, they can also be applied to columns. So the tapering for the main column is the same diameter up to 50%, and then there is tapering. So that's why I have given 2 times. And for the branch, it's a single taper. Okay, to check the lateral drift of the structure, you need to uh, take up the column dimensions, the column deflections, either from the tables or from the graphical user interface. Yes, it is an open shed. Yes, the recording of the webinar uh, will be shared. It will be available on our website as well as on YouTube, on our YouTube channel. Yes, you can taper not only you know uh, pipe sections. You can also taper eye sections like PEB sheds. Yes, ETABS also supports the transfer of IFC files. The wind pressure coefficients, these have been applied for demonstration purposes. Tapered sections can also be done for RCC members as well. I will also be okay. For modeling the truss, it is always wise that you make it into segments in the DXF file. Okay, the column unbraced lengths, they are calculated by the program depending on the frame type or the effective lengths rather are calculated on the frame type, whether it is sway or non-sway. So I think I have answered most of the questions. Some are repetitive, but if there are any more queries which I may not have addressed, you can write to us at support@csiespl.in. And we will be sharing the DXF files uh, through our website so that you can use it for creating the DXF models in your design offices or for your practice as well. So thank you very much for joining in, and we will meet again in the next